morning, everyone. Today we are going to we will continue studying chapter 4. As you know that we already started, but from the back we finished 1/3 of it, and we are going to deal with chapter 4 till we finish it. The chapter 4 actually is a start of stoichiometry, which means the calculations, chemical calculations. So we are going to do that. We have 4 items for the core. State the formulae of elements and compound names in the subject content. Define the molecular formula of a compound as the number and type of different atoms in one molecule. Deduce the formula of a simple compound from the relative number of atoms present in a model or a diagrammatic representation. Construct word equations and simple equations to show how reactants form products, including state sample. And then supplements had more 4, which start with define the empirical formula of a compound at the simplest whole number ratio of the different atoms or ions in a compound. Deduce the formula of an ionic compound from the relative numbers of the ions present in a model of a diagrammatic representation or from the charges on the ions, and also construct simple equation and deduce the simple equation. So all these things are going to be added to your, and we will follow it one by one to complete chapter 4. Let us go together and fight for chapter 4. Just I would like you to pay attention for this, because those are calculations, and I promise you are going to be pro when you finish chapter 4. Let us go. What I'm going to say here is very interesting. We have different types of elements. How scientists organize these elements in order to make our study easy. This is number 1. Second, in order to make everything simple and we can use some sort of information very easy and very punctual. They come out with something called the periodic table of elements. And I know that you have some knowledge about it. I don't want here to discuss the periodic table of elements, but it comes on the table because or I brought it, I bring it to the on the table in order to understand how those elements are being named. It's called chemical nomenclature. Chemical nomenclature. So how we name them. Okay, all elements are either named after their English name or after their Latin name. So I have some which are the most with English names, but also I have some which are little, but they come or derived from Latin names. So why this? Is it confusing? No, because this happens for different reasons, but the most important reason is to differentiate between all these elements. I have 115 element. I wouldn't like to be confused between two elements because they have the same symbol. So I need 115 symbol to differentiate between those. And if there is any new discoveries, they must have symbols that are not present. They must invent new ones. So let us start with the elements that derived from their names derived from English origin. But before that, chemical symbol is a letter or groups of letters. A chemical symbol is a letter or groups of letters representing an element in a chemical formula. So this is one of the most important purposes of making chemical symbol. Now let us move forward and try to understand the English version, how the English version comes. So each symbol is either one letter or groups of letters. For example, carbon is one letter, nitrogen is one letter, sulfur is one letter, oxygen is one letter, hydrogen is one letter, fluorine is one letter, phosphorus is one letter, boron is one letter. All these are elements with one letter. And this letter comprise the first letter of that start the name. For example, carbon starts with C, and for this reason C is the symbol of carbon. One letter, and this letter is the first letter in the carbon name. Nitrogen is one letter, but it is also the first letter in the word nitrogen. Sulfur is one letter, but it is the S, the first letter in sulfur. Phosphorus, P, is one letter, but still it is the first letter in the word phosphorus. Oxygen is one letter, but it is the O, the first letter in the word oxygen. Hydrogen is one letter, but it is the first letter, the H is the first letter in the word hydrogen. Boron is one letter, but it is still, the B is the first of boron, and so on. So if I have the first letter of it, it is part of the symbol. But if we see calcium, chlorine, cesium, all these are elements start with C. And if we write all of them in C and we stop at this, we can have the symbol of carbon will be C, the symbol of calcium will be C, The symbol of cesium will be C. The symbol of chlorine will be C, and so on. In order to avoid redundancy and to avoid repetition of using the symbol for more than one element, we add another letter. So calcium starts with C. The second letter is A. So we are going to have it Ca. Chlor. The first letter is C. The second letter is H. The third letter is L. So we are going to use this third letter. Yeah. Which is which is L. CHL. So it's going to be Cl. Cesium. We have CS because S is the third letter. Cobalt start with C and the second letter is O. So we use the second letter and the symbol is CO. So this is one of the way to differentiate between the samples and not repeat a simple, to differentiate between simples and not repeat a simple or use a simple for more than one element. Also, I have N, nitrogen. Nitrogen start with N, so it goes for N. Only N. Nickel is also start with N. But in order to differentiate it between nickel and nitrogen, we use I with nickel, so it's going to be Ni. Ni. And this is a good example of that. I will add sodium here, but we are going to see the sodium in different. Sodium is Na. We add A to N in order to differentiate it between N and Na and Ni, because those are different. They are three different items. It's not one items. They are different. So we have to understand how we name it and how we do that. Also, we have sulfur. Sulfur is S because sulfur starts with S. If you would like to apply that to silicon, it's going to be two items that have S. In order to differentiate between them, we add I to silicon. So it becomes Si. And this is very important to understand it. It's very, very important to understand how we name it and why there is one with one word and the other with two. We have phosphorus, which is B. P is for phosphorus. And we have lead, which is PP. We are going to know from where PP comes, but PP for phosphorus. And this is also the differentiate between them. It is very, very important to understand these things. It is not easy, but we have to do that. Also, we have other ones that have two, like aluminum, Al, lithium, Li, and also because there are others we start with L or A. Okay, let us go forward and see what is going on. In the previous scene, we say that there are some of the elements the name of these elements derived from English source or English language, and the others comes from the Latin language. And so here we would like to see how this makes difference. So for example, silver, which derived from silver is the name of um, in English, but if we use it, we are going to see Si, and Si is like silicon. So in order to go away from this, we go to the Latin name, and the Latin name is argentum. It comes like Argentina. Argentina is the silver land. The country Argentina, where Messi is there, it comes from Silverland. It means silver land. So it is Argentum. Argentum. And Argentum, we take the A and the G, and here we have the silver. Ag. Ag. The silver. The gold is aurum. Au. And you understand that we have also aluminum, which is Al. So we have this aluminum. Copper is coprum. Coprum. So it comes Cu instead of Co. Why we don't take Co? Because we have cobalt, which is Co. We don't want to confuse ourselves using one symbol for two elements. So we go for the Latin name, which is coprum, and here we name it Cu. Sodium, we don't have So or Sd. Both of them, we have them in another ones. So we use the word natrium. Natrium. Natrium is the Latin name of sodium. And this is why the sodium is Na, not So or Sd. Potassium. Potassium in Latin is called kalium. And this is why it is K, not P. Because P is for phosphorus. P is for phosphorus. So we changed here potassium into kalium, and kalium starts with K, and it is just K. Iron, iron, iron. It is ferrum, 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 which is Fe. It comes from ferrum. And lead, it is not Le or La or Ld. It is plumbum. And this is why it is Pp. Pp. So now you know that the element name either come from an English language or comes from Latin language. In pose, we may use one word, one letter, like kalium, which is potassium, or two letters like copper, which is coprum, okay, or natrium, Na, or also we can use one like phosphorus, and so on. So now you understand that how elements names come from, and by time we are going to study the periodic table in details so you can understand more about that. Let us go forward. Here we are going to move forward. Um, so when we have atoms and those atoms reacts with each other, we are going to name the product as ion or ionic compound or covalent compound, regardless of the details. But this ion contains charge. When it contains charge, it's no longer an atom. It is an ion. When it contains charge, it's no longer an atom. It is an ion. The difference between ions and neutral atoms, that atoms contain the same number of protons and also the same number of electrons. Ions are different. Ions may have more protons than electrons, or they may have more electrons than protons. And we know that if we have proton, that means we have positive charge. And if we have electron, that means we have a negative charge. So if there are difference, the difference between them will tell us whether this ion is a positively charged ion or negatively charged ion. Now let us go and discuss this about what we have here. Here I have magnesium ion. The magnesium ion is +2. Why? Because magnesium loses ions when it reacts. It loses ions. Ions will be lost during reaction. So the protons are going to be more than the electrons in this ion, and this is why it is 2+, because the positive charges, which are protons, are more by 2 than the electrons. The same thing for calcium ion. It is +2 or 2+, because it contains more protons than electrons. Let us go for another thing. Those are nonmetals, which is phosphorus or phosphide and chloride ions. Both of them, they gain electrons. So they gain from outside an extra negative charge. And this is why they are negatively charged ion, because they pull electrons from other cells, like this one here. This is ionic bond. So here an electron, here an electron. This is minus. That means it gains more ions from this one. Let us say yellow and green. So the yellow atom gives an electron to the green ion, which is, or the green atoms. So this becomes an a positively charged ion because it loses one electron or 2 electrons depending on how much, but since it is 1 plus, we are going to have it together as 1. And here this gains more, gains 2 for example, so it's going to be 2 minus. Now let us go for this one, regardless of what they wrote here. I have purple and blue atoms. The blue atoms share electron with this one. So in some time they share it. It doesn't lose it, it just share it. Okay? It doesn't lose it. Okay, if we have, this is an electron. If I give this electron this way, so this one loses the electron and this one had the electron. So this is loses. It hasn't any electron in it. But this one gain it. We add to it electron. But if they both take the electron this way, that means they share it. None of them lose anyone. So they are the same. They just share it. Okay? So here, at some point, it's going to be fulfilled. And here also, at some point, it's to be fulfilled. But in some time, I'm going to tell you this when we come to it. At some point, one of them should be positive and the other one should be negative. We will talk about this later, not now. But I just want you to know that the ions have charge, regardless of whether it is positive charge or negative charge. Previously, or I mean in this lecture or in this period, we finish anything about the elements. So we deal with elements. But sometimes I have some groups, we call them compound ions, and those groups, they work together. They work together as one ion. Okay, so we would like to talk a little about them and understand how we can deal with them. So a compound ion, it is an ion made up of several atoms covalently bonded together and with an overall charge. Can also be called a molecular ion or negatively charged ion. Negatively charged compound ions containing oxygen can be called oxynium, oxonions. So those are group of elements work together as a group, not as one, not as individuals or singles. They work as a group like this. So the group is called nitrate. The whole group is nitrate. And the whole group here is called sulfate. It is not sulfur alone or oxygen alone. It is not nitrogen alone or oxygen alone. However, nitrate is composed of one nitrogen ion plus 3 oxygen ions. Sulfate is formed of or comprised by 1 sulfur ion and 4 oxygen ions. And they are covalently work together like this, you see. Also, I don't want you to take care a lot of this. Just you understand what I meant by my words. Now, let us go here. I wrote in red. I put those into parentheses. and then I wrote -1. The same thing here, -2. So what does it mean? It means that the whole group had a negative charge equal -1. And this means the sulfate or the whole group has this charge, -2. Okay? We are going to understand from where this charge comes in the next slides. We have to understand this table and also to memorize it. It is very important. And here we would like to speak about the monatomic and the polyatomic ions. As we said, that atoms react with each other to make compounds. And sometimes we have groups of atoms that work together. Whenever we have group of atoms, we put them into parentheses, and then we will see how they react together. Here, I would like you to memorize this in order to work with them differently. Here we have an ID ending ions. Also here is the symbol of these ions. Also we have ATE ending ions. That means ions ends with ATE. And these are the symbol of them. And here we have also the ITE ending ions. That means ion that ends with ITE. And this is their symbols. Now, let us go for the first one, bromide. It comes from the brom, which is Br, and it is -1. Chloride, Cl, -1. Fluoride, F, -1. Hydroxide, OH, which is here a group, and -1. Iodide, I, -1. Nitride, N, -3. Oxide, O, -2. Phosphide, B, -3. Sulfide, S, -2. And be careful, I just order them based on the alphabetical, nothing else. So there is nothing to see that they have to be like this. No, it is just alphabetically arranged. Now, if we are going to the 8, which is ATE ending ions, like the bicarbonate, which the symbol of it is HCO3, parentheses, -1. Bromate, PrO2, -1. Carbonate, chlorate, hydrogen sulfate, nitrate, phosphate, sulfate, phosphate. I think phosphate here is double. And then ITE, chloride, hypochlorite, nitrite, sulfide, phosphide. And also there is a special ions like ammonium, which is NH4 +1, and this is the only one that +1, and permanganate MnO4 -1. We are going to know how we are going to do this minus, but or plus. We are going to do that, but you have to memorize this, please. I keep telling you that there are groups, and those groups work together, and their group do something, and they have charts. So how you can calculate this charge for each group? It is not difficult. It is very easy. And remember our 5 steps protocols. We are going to do the same thing. Now, for example, this is the sulfate ion. The sulfate ion is formed of S, which is sulfur, and 1 and then 4 of this. Let us go here and see how we calculate this one. So sulfur and oxygen are members of group 6. So we use the periodic table. It is to say each of them contains 6 valence electrons. The sulfate polyanions contains one sulfur ion, and 4 oxygen ions. Those are 4 oxygen ions. Sulfur ion share his 6 electrons as a donor. So this is the 6 ones, and positive charge. Explain why it is positive charge. While 2 of the oxygen ions receive 2 electrons from the sulfur ion, the other 2 receive 1 electrons. Oxygen is negatively charged. Why? Okay, so first I'm going to determine which type of atoms work with this. It is 1 sulfur atom or ion and 4 oxygen ions. So those is already I have them. Each of them, the sulfur and oxygen, are of 6 valence ions at the end shield. I'm not going to talk about this. It is just we take it now at this, and then after, when we come to distributing everything and how we know the orbits and all this, we are going to discuss this, and also we are going to discuss it during the valency when we study the valency. Sulfur ion shares his 6. So the sulfur ions gives his 6 electrons. It share with them. And if you look here, it's going to share here with 2, here with 2, and here with 1, and here with 1. And this is what I said here. Okay, I have the sulfur and oxygen. Which one of them gives and which one of them takes? In this case, I'm going to say that sulfur is the giver, the donor, while the oxygen is the receiver of the electron. Why? Because oxygen is on the top of the 6, while sulfur comes after it, and this makes it more energetic. So it's more liable to take ion rather than to leave the ion, leave one of these ion or lost one of its ion, because it has less number of orbits, and because it has this less number of orbits, the electrostatic force between the nucleus of the oxygen and the last orbit is more stronger than the one between the sulfur nucleus and the last orbit of it. So it is easy for the sulfur to lose theoretically ions, than gain ions. And this is why sulfur is positive while oxygen is negative. Okay, so I have 6 positive while I have also 4 ions. 4 multiplied by 2 equal 8, so 8 minus 6 equal minus 2. Minus 8 minus 6 equal minus 2. So here. So sulfur ions is of 6 positive, while the 4 oxygen ions are 2 multiplied by 4. So here thus 6 plus minus 8 minus equal minus 2. As a result, sulfate ion charge is minus 2. Be careful. I put minus and positive in red, so be careful about this. The same thing we are going to deal when we are going to deal with carbonate. Carbonate is form of carbon and 1 carbon atom and 3 oxygen atoms. The carbon atoms has 4 in its end or last orbit, while the oxygen has 6 in the last object. So here still carbon is positively charged, while the oxygen is negatively charged. And then when we multiply each one, so carbon ion is 4 plus, while the 4 oxygen ions are 2 multiplied by 3, which are 3 equal minus 6. So 4 plus minus 6 minus equal 2 minus. As a result, carbonate ion charge is minus 2. And this is very important. If you follow this program or this 5 steps protocol, you are going to solve any problem and you are going to be pro. I'm going to let us go for the other ones. In this scene, we are going to use ammonium ion and nitrite ion. I'm not gonna explain this for you. I want you to train it. You just follow my wording and also understand how they are going to do it. So it is easy. There is nothing difficult. You just have to do it the same way that I have taught you. And I know you are going to make it. I left this table for you because I know that you are going to deal with it in a good way, and you are going to just go through it and try to understand it. Use it if you already have some knowledge about it, and you can use it anytime, anywhere. If you have any question, just let me know. We are going to have it as a different chapter. It is your 13th chapter in your course book, so don't worry. We are going to come and finish it. Thank you for listening. Thank you for paying attention to this very important period. We are going to start a lot of things together. So don't worry, you are going to be pro in chapter 4. I'm sure of that. So be careful, and we will continue hard work with each other. If you have anything, just write me any comment, any question in the comment section below. Thank you for listening, and I wish you good time. Next video, maybe 2 or more days, we are going to make an advance, progressive advance, inshallah, in the next video. Thank you and have a good day.